Hello, math students. This is Mr. Ray with another high school math lesson. This lesson is going to be a review of factoring techniques. So the video is geared towards grade 12 students. We're going to be reviewing these four techniques: common factoring, simple trinomial, complex trinomial, difference of squares. I'm also going to be covering off a new type of factoring introduced in grade 12 called sum of cubes and difference of cubes. They're two different methods, but very, very similar. So this will be a new technique. The four previous ones should be review. So I'm not going to spend a lot of time talking about why we do the method. I'm going to be doing lots of examples. I think a little over 20 examples of all these combined. The important thing to remember when you're doing factoring is, well, the first thing is you always want to try common factoring first, okay? Even if you have a temptation and you say, hey, that looks like a complex trinomial, or that looks like a difference of squares, try to do the common factoring first all the time. Because if you don't, you may leave out a common factor, and in that case, you will have factored it, but not fully factored it. So always do the common factoring first. And the other thing that makes common factoring a wise choice to try first is because sometimes, and I'll do an example of it, you have something that looks like a complex trinomial that's actually a simple trinomial that has a common factor that you can take out right away, and makes it a much easier question. Okay, so just remember when you're doing factoring, any of these methods, it's super easy to check your answer. And the way you do that is you just, once you get your factors, you multiply your factors and simplify, and you should get the original question. Okay, so when you do factoring, the nice thing about factoring is you can always check your work. Okay, you should never leave a factoring question going, well, I hope I got that one right, not sure. You can always check your answer, and you'll either know, yeah, I got it, or I did something wrong. Okay, so I'm going to start off with some common factoring questions. So this is always the first technique that you learned in grade 10, reviewed in grade 11. Okay, so I'll start off with something simple and work our way up. I'll just do 3 examples for this. So if I had 4x minus 16, okay, when you common factoring, you're looking for a term that you could divide evenly into all the terms of what you're trying to factor. So in this case, okay, if you want to break it up at first, after you've done this a while, it becomes very quick. But if you're just reviewing this, you look at the numbers first, the number parts of the terms. So I have a 4 and a negative 16. I can quickly determine that I can divide both of those by 4. So the 4 is part of the common factor. It could be all of it. Then you look for the variables. Now in this case, I have an x in this term, no variable in this term. So I can't factor any variable out of both terms. So 4 is the sole common factor, the greatest common factor. And that's an important thing. You want to take the greatest common factor. So you may have said, well, that, I can divide 2 into both of these, which is true, but it's not the biggest number you can divide out. So you always want to get the greatest common factor. Otherwise, again, it won't be fully factored. So if we take the 4 out, that part's the common factor, and then we take the common factor and we just divide each of these terms by that common factor. So dividing a 4x by 4, we get an x, and dividing the negative 16 by 4, we get a negative 4, and that's done. And again, you could check your work by expanding this. You should get back the original answer. Okay. Second example, say we had 3x squared plus 9x. So again, in this case, look for a numerical common factor. So I have a 3 and a 9. So positive 9, so I can divide both those by 3. That's the largest that can possibly go in. So 3 will be part of my greatest common factor. And again, now I look at the variable part. Both of these terms have x's, so for sure I can factor an x out. And then it's just a matter of what exponent it gets. So the exponent of the common factor will be the lowest of the exponents of each of the terms. Okay, so I have an exponent of 2 there, I have an exponent of 1 implied there. So I can only take 1x out of both. I can't take x squared out of both. So that's my greatest common factor. And now I just divide each of these terms by 3x. So 3x squared divided by 3x is x. And positive 9x divided by 3x, that's just going to be a 3. Positive 3. And again, you can check. That's going to be 3x squared. That's going to be 9x. Good. Okay. All right. So let's try something a little more complicated to end this. We're going to have 3 terms and multiple variables. So 21x cubed y fourth minus 35x squared y squared. So get that in. Plus 7x to the 5th y cubed. Okay. Now this is a little trickier for 2 reasons. One, we've got 3 terms instead of the previous ones were binomials. They had 2. This is a trinomial, but it's not your trinomial factoring because it's got x's and y's in it. So the first thing, again, don't try to do everything at once. Break it down into the components of the common factor. So in terms of the numerical part of the coefficients, I've got a 21, negative 35, positive 7. Okay, 7 goes into all of those evenly, but nothing higher because of that. That's the coefficient there. So I'm going to put a 7 first. Now, sometimes you get the question of, well, what sign should I make? Because I have a negative 35 there. But even if I had a negative 7 over here, I tend to always, make it the same sign as the first term. It's not wrong if you change it, but you have to be careful with the sign of what's left over. So I would always make my common factor, well, not always, but most of the time I'd make my common factor a positive sign and then work through that. So let's look at the next part. So I've actually got 2 variables, x and y. So I again break that down. Look at the x's first. So I've got x cubed, x squared, x to the 5th. So for sure, I can factor out an x. Now it's a matter of what's the exponent. You take the lowest of the 3 exponents. I have a 3 there, a 2 there, and a 5 there. So I'm going to use that 2. So it's 7x squared so far. And then the y, I've got y to the 4th, y squared, y cubed. So that would be a y squared as your greatest common factor. All right. Now, what's going to be left over? So if you look back at the previous 2 examples, I had in the brackets, when I divided out, I had 2 terms in the brackets, and that's because I had 2 terms in the original question. Okay. So if I have 3 terms in the original question, I'm going to have 3 terms inside the bracket. Okay, so I can put a little template there to remind me I should have 3 terms. They're going to be separated by plus or minus signs. Okay, so now I just divide. I divide 21x cubed y to the 4th by this. The other way of thinking about it, and this is the way that I would do it, is I ask myself, what do I have to multiply this common factor by to get this first term? So to go from 7 to 21, I would need a 3 to multiply. X squared to x cubed, well, I need one more x. Y squared to y to the 4th, I would need to multiply by y squared. Okay, so, and again, you could check this right away if you wanted to. If I multiply these 2 together, I should get the first term. Okay, now we move to the second term. So I have negative 35x squared y squared. Okay, so I pretty much know that this should be negative, but if I divide negative 35 by 7, That's going to be a negative 5. Or you could ask yourself, what do I have to multiply 7 by to get negative 35? Negative 5 again. And then you look at the variable parts. X squared turns into x squared, so I didn't have to do anything. Y squared turns, I want to get that to y squared, well, I don't have to do anything there. So I don't put an x or y here, because if I put x's or y's here, it would increase the exponent when I check my work, when I multiply it out. So in this case, I just leave it as a minus 5. Okay, and you can check that, multiply this, you get a negative 35x squared y squared. And then finally, the last term, 7x to the 5th y cubed. So if I divide this out, or ask myself, what do I have to multiply 7 to get 7? Well, that's just, we know it's positive. It's just 1. I don't have to put the 1 there. I could. But then I check the variable parts, x squared to x to the 5th. The difference would be I need to multiply by x cubed. And y squared to y cubed, that means I have to multiply by another y. And that would be my final answer. Okay. Now, like I said, you could put a 1 here. It doesn't make the answer any different, but usually if a coefficient is 1, we just leave it without the coefficient. That's kind of math standard practice. Okay, so that's a quick review of common factoring. Hopefully that brings back all the important points to you. Remember, you can always check your work, like I've said. Okay, now the second type. So we've done common factoring. Go back up here. We're going to look at simple trinomials. Okay, so now we first learned how to do this factoring type of factoring in grade 10. So we called it simple trinomial just because the fact that what you start with has 3 terms, but that's a little simplistic. So if I'll put my first example here to show you what I mean by that. So here is our first trinomial that we're going to factor. And you can agree it's a trinomial, but you can't do this type of factoring for all trinomials. Just because there's 3 terms doesn't mean this works. It's really a quadratic expression you have to be working with. Okay, and we didn't really know what that was when we learned how to do this type of factoring in grade 10. We learned this later on in the course, so we still call it simple trinomial because that's kind of the way we learned it or taught it. But the thing that works for this is it's a quadratic, so that means you'll have a squared term, a variable squared term, plus another term or minus a term that has the variable, and plus a constant term. Okay, so that's what we really mean by trinomial. Okay, it's really a quadratic. Now the simple part comes from the fact that the squared term has a coefficient of 1. Okay, if this was a 3x squared, it would not be a simple trinomial factoring question. It would be a complex trinomial factoring question. Okay, so the simple part comes from coefficient, and the trinomial is really, it's a quadratic expression. Okay, now you can't just pick any random, like this one will factor, but if I change this to a 9, it wouldn't be factorable. So factoring doesn't always work. You can't assume that everything's factorable. Most expressions are not factorable, but as you remember from grade 10, 11, most of the ones you get, when you're asked to factor something, 99% of the time it is factorable. Okay, so just because you don't know what to do doesn't make it not factorable. Okay, so let's look at this, and I'm going to go through the first one a little bit slower. As soon as I see that this is a simple trinomial, I always do this step. Okay, I know that if this is factorable, that it definitely will factor into 2 binomials. Okay, and so I'm going to have binomial times binomial. This is your old FOIL thing. And in order to get an x squared term, I have to have the first 2 terms as x. And that's when I do my FOIL, the first will give me the x squared. And then there's going to be 2 numbers here that I have to figure out. those two numbers, when I multiply them together, will give me that, which is the product of the two numbers. And when I add these two numbers together with the correct signs, of course, I'll get a positive 7. Okay, so if you remember, so they add these two numbers that I'm looking for, add to the b value here. If you think of x squared plus bx plus c, so they add to the b value and they multiply to the c value. Okay, so all it is a matter of is finding those two numbers that work for that, and there won't be, there won't be more than one combination that works. So it's up to you to find it. Now, if you can think, so basically what I would do when I'm starting off is say, okay, the two numbers I'm looking for, they multiply. So I do my multiply sign with a circle around it, multiplies to 10, and they add to 7. Okay, so if you can think of those two numbers right without doing anything else, then you would just take the two numbers and put them here. Okay, you don't, a lot of the times, most of the time, you should be able to do this in your head. But if you have a little bit of a mind cramp and you can't quite get it, then I would make this little t-chart. Okay, and what the t-chart will do is we're going to start off with the product of 10. What are the combinations of numbers that will give, when I multiply them, will give me 10? So I always start off with 1 and the number itself. Okay, and then I methodically go through the combinations. So I'll increase this to 2. Does 2 go into 10? Yes, it does. So that if I divide by 10 by 2, I get 5. So 2 times 5 gives me 10. 3, well, 3 doesn't work because it doesn't go into 10. 4 doesn't go into 10 evenly. 5, well, we've already got 5 here. So as soon as you get to the number and it's already on the second part of the pair, you can stop. So those are the only two numbers that multiply to 5. Okay. Now, because these two numbers are positive, you can assume that you don't have to worry about the sign here. There won't be any negatives here. But the way we're going to think about this when we get to some harder ones with different signs is think of it this way. The two numbers I'm looking for multiply to something positive. Okay, don't worry about the 10 at this point. So they multiply to something positive. That means they're either both positive or both negative. Okay, but they add to something positive. So that implies that the two numbers can't be negative, because if you add them together, you get a negative sum. So the two numbers are both positive. So I don't have to change the signs here. Okay, so now I just go through and add the two numbers together. I get 11 and I get 7. And of course, I'm looking for 7. So 2 and 5 are the, and it's positive 2, positive 5 are the two second terms in your binomial factors. Okay, and again, you can check, you can do your FOIL and get that. But I think by the time you're in grade 12, you really shouldn't be doing this unless you have a really complicated trinomial here with maybe 36 and 100 here or something. Maybe you can't think of them off the top of your head, or you've tried what you think should work and can't find it. Then I would say go through this methodically, and you'll probably find the pair that you passed over before. Okay, so next example, we've got x squared minus 7x plus 12. Okay, so again, this is a simple trinomial. So I know I've got if this is factorable, I will have factors that look like this. And it's a matter of finding the two numbers that go there. Okay, I like doing it this way because you also feel like you've accomplished something. It feels like you've got half the work done when you really haven't had to do anything. Okay, so now you think, okay, the two numbers here multiplies to 12, positive 12, and they add to negative 7. So again, if you can think of the two numbers, and I'm sure most of you would, you can put those two numbers in right away, you're done. These should take a matter of seconds to do, as long as the numbers aren't too large. Okay, now again, if you didn't get the right answer, or you couldn't figure out the right numbers to give you that, then again, Yeah, this should be a little lower. Just redo this. Okay, so again, start off, and I'm not going to worry about the sign yet. So I got 1 and 12, 2 and 6, 3 and 4, and I can see I backed onto the 4 over here, so we know we're done. Okay, now let's think about the signs of these numbers because they multiply to positive 12. Okay, so that means if multiplied to something positive, they're either both positive or both negative. You look over here, when you add them together, you get something negative. Okay, so that means both numbers in each pair are negative. That's the only way you can get them to add up to something negative and multiply to something positive. So add them together, negative 1, negative 12, we got negative 7 here, and we were looking for negative 7. So the two numbers were minus 3 and minus 4. Okay, let's try a few more examples. Let's do another 3 of the simple trinomial. Okay, so let's switch it up a little bit because we get so used to using x in our quadratics. Let's just change the variable to keep you guys honest. Y squared minus y minus 20. Okay, so again, want to feel good about my work even though I haven't done anything. I do know that this, if it does factor, it will factor into 2 binomials, and both of them should start with a y, and then there'll be 2 numbers here. And again, so it's really no different than having an x squared and an x here. Just remember to put your answer with the right variable. Okay, so I'm looking for 2 numbers and they multiply to negative 20, and they add to, now the fact that that's a minus y, remember if you don't see a coefficient there, in this case it's a negative 1 is the coefficient, so it adds to negative 1. Okay, so now when I do my list of factors here, at the beginning, I'm not going to concern myself with the sign. So I've got 1 and 20, 2 and 10, 3 doesn't work, 4 and 5 go together, and then we're back to the 5, so we're done. Okay, so let's think about the sign. Okay, so in this case, the 2 numbers multiply to negative, something negative. So that means that I've got one of these numbers has to be negative, the other has to be positive. But they add to something negative. So what that tells you is that the larger number has this sign. Okay, it has to be, larger number has to be negative for it to add to be a negative sum. So in this case, the larger number is negative. So that's going to be the numbers down the right here because these are all the larger. So I'll just insert my 5s, my negative sign in there, add them together. Negative 9, negative 8, and negative 1. Looking for negative 1, so there's my combination that works. So I got y plus 4, y minus 5. Now, does it matter which binomial put it into? No. I could just as easily put y minus 5, y plus 4. I just used the same order I had them here. Okay, and again, you can check, do your expanding, your FOIL. You should get back to the original question. Okay. Oh, I got the numbers switched up here. So this should be a 6, just to be consistent. 6 and 7. Okay. All right, so in this case, I'll try another variable. How about an a squared minus 9a minus 36? Now again, remember what I said earlier. These questions have been thought out. I'm not just pulling these numbers out of a hat, because if I did, it probably wouldn't be factorable. Okay, so now it's very possible that you could get a trinomial / quadratic and try to factor it, and you can't find the 2 numbers that work. That means it's not factorable. Okay, and that's very possible, but not likely when you get a series of questions to factor. You might see 1 or 2, but generally, in real life, most expressions are not factorable. Okay, so in this case, I'm going to write this out. I know this is going to be, if it does factor, it'll factor into something that looks like this. Those are A's, by the way, and you're going to have two numbers there. So what are those two numbers? Well, we know that they multiply to negative 36, and they add to get negative 9. So I'm looking at the factors of 36. So start with 1, work your way up. So 136, 218, 3 works with 12, 4 works with 9, 5, 6. So 6 and 6. Okay, now let's think about the sign. Okay, so they multiply to something negative, so that means you have one positive, one negative. When you add them together, you get something negative, so it's just like the previous example. The larger number will be negative from each pair. So I insert a negative sign in front of the bigger number. In this case, they're both the same, so it doesn't really matter. And then when we add them together, the two pairs, or the pair, we get negative 35, negative 16, negative 9, negative 5, and 0. Okay, we were looking for a negative 9, so those are the two numbers. So we've got an A plus 3 and an A minus 12. Okay, so hopefully this is reminding you of how to do these. And again, like I said, most of the time you shouldn't have to do this with the tables. You should just be able to, after a while, you just know, oh, that's a 12 and a 3, and figure out what the signs are in your head. Okay, the last one for the simple trinomial, it's going to look like this. Okay, and you're probably saying, well, wait a minute, didn't you just say that if you have something other than 1, then it should be complex? Definitely, and that's true, but also remember what I said earlier. If you see something that looks like complex, you should see if you can factor in something out. Now, in this case, I won't be able to factor an x out, okay, because there's no x in the third term. It's a constant, but you can see numerically I can factor a 2 out of every term. So when I do that, the common factor of 2, I divide each of the terms by 2, I get x squared plus 7x plus 10. And if you remember, that was the very first question I gave you in this section. So that actually has factors of x plus 2, x plus 5. I won't redo it, but you would do it the same way. The important thing is, to recognize that you can factor out first. But what I see a lot of times in grade 10 and 11 is, you'll take the 2 out and then you'll forget about it and put your final answer as just these two pairs. And obviously that would be wrong. And you should be able to see that if you expanded this, you would not get this. You would get x squared plus 7x plus 10. Okay, so and that's one of the real benefits of trying to common factor first, because we actually turned this into a much easier question. Okay, now if you say you didn't recognize this was a common factor, you could do the complex method, well, you'll see later on. If you didn't notice you had a common factor, you should probably see it by the time you get to one of your last answers, because maybe if you had, instead of this 2 times x plus 2, you might have, instead of having that, you might have had a 2x plus 4 as a factor, and the x plus 5 would still be x plus 5. And then you look at it and go, well, wait a minute, I can factor a 2 out of that one, and then it becomes this, and then you realize, oh, I should have common factored right at the start. It would have made my life a lot easier. Okay, so that's the simple trinomial factoring method. Most of this should be done in your head, especially once you're in grade 12. So let's look at the complex trinomial factoring. Okay. Now, so remember, the difference between what we're about to do and what we just did is complex trinomial factoring, it looks like you have a you have a coefficient other than 1 for your x squared term. Okay. Now, I just wanted to show you something quickly here while I thought of it. Let's look at this example here. Okay, so you know how to do that. Now, sometimes you get thrown a little curveball because every example we've had so far, the initial term is positive, right? But what if I gave you what if I just flipped the signs of all these? So maybe I had factor negative a squared plus 9a plus 36, okay? What I would do personally, and I've seen other people do it other methods, and you know it works. So as long as you get the right answer, I don't really care how you got it. But what I would do in this case, since your leading term here, your highest degree term, is negative, I would actually factor the negative out first. So it's like having a common factor of -1, which everything you could do. So if I factor out the negative, it basically flips all the signs. So I'd have a squared plus, sorry, not plus, that would flip to a minus 9a. And then a minus 36. Okay, and then, you know, you could treat that as a -1 if you'd like. And then you notice this is exactly the same as that. So you would do your work for that. You would come up with an answer of a plus 3, a minus 12. Okay. You could leave it like that, or if you want to be impressive, you could actually multiply the -1 into one of these two terms. It's not terms, one of these two factors. So personally, okay, and you can choose. So I could change this to negative a minus 3 times a minus 12, or I could multiply the negative sign, the -1 into here. And the reason why I would do that is because there's already a negative there. So if I multiply this by -1, I get negative a plus 12, or I could flip them around and change that to 12 minus a. So what I did here is multiply the -1 into that factor. You'd never multiply it into both, so don't do that. So when I multiply into this, that changes to negative a, that changes to positive 12. So I could put it as minus a plus 12, or to make it look a little nicer, 12 minus a. So it looks like I almost just flipped the position of those two terms. So that's how you would handle something with a leading negative term in a trinomial factoring method. Okay, and that also applies to complex as well. Okay, now complex trinomial factoring. There's actually several different methods of doing this. Okay, in grade 10, you probably learned decomposition method. So I'm going to show you a couple of examples using that. I'm also going to do a sidebar, do the same question using another method. Now this other method has many different names. I call it intelligent guess and check, but it could be the cross method or guess and check or box method. I've heard all sorts of different names. And there's a third method called Australian. If you understand that and know what you're doing, you definitely can use that. I'm interested in you getting the correct answer. I don't teach Australian method, but if you, like I said, if you were taught it and it works for you, great. Okay. So the first example we have here is 3n squared minus 8n plus 4. Okay, now again, if you saw this question, you probably wouldn't be told this is complex trinomial, but the way you recognize that it is you know, the 3 here. Now again, you should try to factor this right away, because if you know if you can get rid of this 3 by factoring it out, it becomes a totally better question in terms of speed. Okay, but in this case, I can't factor anything out of here. There's no common factor. So I just proceed with, now the way the decomposition method works, it basically, what we do is we split the middle term into two terms that add to that term, and the first and the last terms stay the same. So we turned it in from a trinomial to a quadrinomial. And the reason why we're going to do that is so we can then factor by grouping. Okay, so it's got multi-steps in this method here. Now, the problem with this, well, you can't just pick any two numbers that combine to -8. I can't just say, oh, let's do -5, -3, or -10, +2. There's a very unique way that we want to decompose this. Remember, decompose means break down. Okay, and the way we find that is very similar to the method we just used. I'm going to put this a little closer. So we still use this t-chart. Now the thing that changes is, okay, we still know the two numbers are going to add to -8 as before. So they add to whatever b is, but they multiply to the product of these two numbers, the a and the c, multiplied together. So that's going to be a 12. So we know they're going to multiply to 12, add to -8. Okay, so if you can think of what they are right away, I'll just pick it out so we don't spend too much time. So they multiply to -12, add to -8, so that's going to be -2, -6. Okay, so -2, -6. I put them in here. Now don't forget, it's not just not -2, -6. It has an n with it. Okay, so this is the decomposition step. We've broken the middle term into two terms that add up to that, but it has to have a very specific method of getting those two numbers. Okay, so if you just guessed at -3, -5, it's not going. You're not going to get any farther here. So what we do now is we're going to factor by grouping. So if you remember factor by grouping, you basically group together the first two terms in brackets. Okay, and this one's a little trickier because the third term has a negative sign here. I actually put that negative sign in between the two sets of brackets. Okay, but I also have to, so that becomes a -6, and because I've factored out a -1 here, I have to factor the -1 out of here. So I basically have to flip the sign of that term. So this is unfortunately, this is a trickier example to start off with, but that's what it is. Okay, if I put that as a plus, that would be wrong, because if I expanded this out and I had that as a plus, a negative, if I was subtracting 4, I'd end up with -4, not +4. So now that we've done that, what we do is we've grouped it. Now we factor the two groups. You take the largest common factor out of the first group. That will be an n. And then when I factor the n out, I get 3n minus 2. All right, now I'm going to just automatically put the minus sign there, and then just look at this and say, what can I factor out of 6n plus 4? That I can factor a 2 out of that. Okay, so when I factor a 2 out of that, I get 3n minus 2. And this is where you cross your fingers and you look at the two binomials in the brackets, and they better be the same. Otherwise, you made a mistake. Okay, either you picked the wrong two numbers here, or you factored incorrectly here. The fact that we got these two the same means that we've got one more step, and hopefully you'll remember what we're doing here. The 3n minus 2 is common to both of these. It's common to this product and to this product. So I can factor the 3n minus 2 out directly. And then what do I have left over? I have an n minus 2. So that would be how you do complex trinomial factoring using decomposition method. And again, check your work. Multiply this out with your FOIL, and you're going to get back to that. So I have a 3n squared, I have a negative 6n, a negative 2n, and a positive 4. Negative 6n plus negative 2n gives you this. And you can see those two numbers came from came from this FOIL down here as well. Okay, so I'm going to show you the intelligent guess and check method. So I'll just draw a line down here. Same question. So 3n squared minus 8n plus 4. So the important things that we look at with the intelligent guess and check is we're going to look at the factors of the a and the c. Okay, so when I look at the factors of 3, there's only one pair, and that's a 1 and a 3. With the 4, I have actually two pairs. I've got a 1 and a 4 and a 2 and a 2. Now I'm not at this stage, I'm not worrying about the sign too much. We'll take care of that later on. So what the intelligent guess and check means is, and there's very little steps here that have to be done. Okay, so I'm going to just start creating my answer, and I'm going to this is definitely an exercise that has to be done in pencil. Since I only have one option of factors here, I know I'm going to have a 1n and a 3n that multiplied to give 3n squared. Okay, so 1 and the 3 are the two numbers. Now, I could put the n here and the 3n here. I always like to just put the larger of the two first, but it doesn't really matter. And I know this is the only option. The first terms of the two binomials have to be 3n and n, because basically the 3 here is a prime number. The only two factors are 1 and the number. So if you have a question with a prime number as your coefficient, that makes it really easy because you know it's 1 in the number. So if that was a 5 or 7 or 11 or 2, you know exactly what these two are. Okay, so there's no doubt about that. Now this one here, there is a question. It could be a 2 and a 2 or a 1 and a 4. And if it's a 1 and a 4, where does the 1 go? Where does the 4 go? So we're still not too sure. So I use the name intelligent guess and check, and the intelligent part comes from saying when you're given a list of choices of pairs, you always start with the ones that are closest together. So in this case, I'm going to start with 2 and 2, and that's nice because I don't have to decide where does the 2 go, because the 2 goes in both places. Okay, and I'm gonna put that in light pencil because I'm not sure at this point. Okay. Now what I do is I check. Okay, so I know that when I multiply these two, I'm going to get a 4. I know when I multiply these two, I get a 3n squared. The question is, does this combination work and give us a minus 8n? And the way we do that is we basically, that middle term comes from this multiplication, the outside inside. Okay, so what do I get on the outside? I get a 6, and I get a 2. Okay, and so you ask the question, can I make an 8 from a 6 and a 2? I know that's negative, and yes, you can. So if I can if I can create this number by using these, I know that that's the right answer. So I know the 2 and the 2 are right. Now it's just a matter of the sign. So what sign do I need to make the 6 and the 2 that I created? Well, the 6 has to be negative 6 and the 2 has to be negative 2. So this is where the 2n comes from. So I know I put a negative sign there. I also put a negative sign here to get my negative 6n. Okay, so you can see it's very little work, just a lot of kind of inward thinking and mental math that has to be done. And you can see we got the exact same answer. Now, when you're doing factoring in grade 12, you probably saw this in grade 11, that you need to do it fairly quickly. And the decomposition method always takes the same amount of time, which is a fairly long time. Okay, if you compared how long this took to that, you know that this is much quicker. Sometimes this can be quicker if you have to go through all sorts of combinations here, but in general, this is your better option. And when you're doing factoring later on in grade 12, you're going to see that I might have one single question that has 3 different complex trinomial factoring. You can't afford the time really to do this 3 times. And if you have several of those questions, it just gets even bigger. So this is the preferred method. If you're good at this, try to give this one a try because it saves you a lot of time. All right, so let's go to another example here. So we've got question 10. Okay, so I've got 2x squared plus 5x plus 2. Okay, so I'll do one more question where I use both methods, and then from then on I'm going to use the other, just the intelligent guess and check. So I'll start off here with decomposition. I'll do intelligent guess and check over here. So again, you would try to do common factoring here. It doesn't work. So I'm going to decompose the middle term. So I'm going to have 2 terms that combine to create the 5x. Okay, and what are those 2 numbers that go there? Well, I know the 2 numbers add to positive 5 and multiply, don't forget, multiplies to 2 times 2, so multiplies to 4. Okay, so multiplies to 4, I've got 1 and 4, 2 and 2, adds to 5, well, that's definitely that one there. So the 2 numbers are 1 and positive 4. Does it matter where you put these? The correct answer would be no, but if you have a positive and a negative, you'll always want to put the negative first, because as you saw from that last question, it makes it a little tricky when you have a negative sign here and you do your factor by grouping of the second part. So in this case, it's positive 1, positive 4. So I'll put that, and don't forget it's x. Okay, so you can definitely see that this equation this line is the same as the previous one. And now we're going to group first and second, 2x squared plus, I'll just leave it as an x. Okay, and don't forget you have to put a sign in between here when you do your factor by grouping. And it depends on the sign of the third term. So in this case, I don't have to factor out the negative 1 like I did before. I just have the 4x plus 2. Now you do your factor by grouping. So I can factor out an x here, and I get a 2x plus 1 left over, and I factor out a 2 here, and I get a 2x plus 1 working. Cross the fingers. Those are the same. That becomes your first factor, and your second factor is what's left over, so x plus 2. Okay, so that wasn't bad in terms of time. Let's try the same question using intelligent guess and check. So I've got 2x squared plus 5x plus 2. Okay, now this one is ideal because your 2 numbers are both prime numbers. So the only possibility is 1 and 2 for both. Okay. So in this case, I know I'm gonna have a 2x plus or minus a number and an x plus or minus numbers. So remember, I was saying, I could put the x here or the 2x here, it doesn't matter. I just like to put the higher one first. So personal preference. Now, the only question, we know a 1 and a 2 from here, the only 2 possible factors of 2. I know there'll be a 1 and 2 here. The question is, where does the 1 go? Where does the 2 go? So you can actually, look a little bit ahead. So if I imagine if I put a 2 here, okay, that's going to give me a 2x. If I put a 1 here, that would give me a 2x there. Well, that's not going to give me a 4x. That's going to give me 4x, not 5x. So in this case, I need to put the 2 here and the 1 here. That comes from here. So now when I do the outside, I get a 4x and a 5x, sorry, 4x and a 1x gives me a 5x, but the 4x has to be positive, so the plus sign goes there. The 1x also has to be positive to give me 5x, so that goes there, and you can see you get the same answer. And they both were, I mean, this was still quicker by quite a bit, even though we kind of went through that one quickly. Okay, let's try some more. We've got 11, so we got 5x squared minus 18x plus 9. Okay, so this one, numbers are a little bigger. So this time, I mean, you could do the same thing here. Now, the problem is once you start getting bigger numbers with and using the decomposition method, the number you're looking for the decomposition part is going to be 45, and they add to 18. So it does get trickier with the bigger numbers. So we're just going to do intelligent guess and check. So I can see that's a prime number. So the only possible factors of 5 are 1 and 5. And here I've got, for the 9, 1 and 9 and 3 and 3. Okay, so right away I know that one of the factors will start with 5x. The other factor will start with x or 1x. Okay, and then we don't know which of these will work, but intelligent part says, let's start with the middle pair. Now, there's really no scientific reason why you would start with that. It just seems to work quite a bit. Okay, so that's why we chose these. Now, it doesn't always work, but let's just try it out. So I'm going to put the 3 and 3 in very light pencil. Hopefully you can see that. Okay, because I want to be able to erase it if I find out it's wrong. So again, you break it out into the outside and inside. Okay, so the outside I'm going to get 15x. The inside I'm going to get 3x. Can I make a negative 18 from that? Yes, because if I could make this a negative 15 and this a negative 3, that would give us a negative 18. So the 3's were correct. And because I know they both have to be negative, I put a negative sign there, and we're done. So that was pretty quick. That would be way faster than doing decomposition, for sure. Now, you can say, well, you got a little bit lucky because you picked the 3 and the 3 right away. Well, we did. There's some times where, you try that, it doesn't work, and then you try one of these combinations, it doesn't, then you have to flip them around. So sometimes, it does require a few more iterations of trials before it works. Okay, let's do this one here. Change the variable to n. 27n minus 6. Okay, now the last couple of ones we kind of skipped that step of looking for a common factor, right? Or maybe we quickly looked and found out it couldn't. Like, you couldn't do a common factor for either of these, but if you look at this, well, guess what? There is a common factor of 3. Now, unfortunately, it's not going to get rid of the 15, but it's definitely something you should do right off the bat. Your numbers will be smaller, and then you don't have to worry about common factoring later on. Okay, so if I factor a 3 out of here, now I always use the big brackets, square brackets, if I take a common factor out of trinomial. So that's going to give me 5n squared minus 9n minus 2. Okay, now that 3 is definitely one of the factors. Don't drop it, because it would make your answer wrong. Okay, now let's look at this. Well, I have a 5 here and a 2 there. Well, that's great. Those are both prime numbers, so there's only one combination of factors that work. So keep my 3 out there, build my 2 binomial factors. I know one's a 5n, and I know the other one's an n. Okay, I also know that the numbers here are 1 and 2. I don't know which position though. So I can kind of look ahead here. I want to build a 9. So I can kind of see here, I'd like to get a 10 and a 1. So if I put the 2 here, I get a 10, and that will give me a 1, which could create the -9. If I put the 2 here, that's going to give me a 2, and the 1 here would give me a 5. That would give me a 2 and a 5, which I can't create the -9. So the 2 will go here, the 1 will go here. So if I look at what I've got here, if I just look at the number part, forget about the n for a second, I've got a 10 and a 1. So can I use those to create a -9? Sure. If I make the 10 negative, so the 10 comes from here, so the negative sign is part of the negative, is part of the 2, and then I want this to be positive 1n, so I'd have -10 plus 1, which gives me -9. Okay, so hopefully if you haven't used this method, hopefully you're seeing how you can do it and see the benefits of how much quicker it is once you get rolling. I'll do 2 more of these, and then we'll move on to the last methods. I know students like to see lots of examples of these ones, just because they're a little bit tricky to learn. Okay, so 4x squared minus 35x plus 49. Okay, so a quick check for common factor, and there's nothing. I can factor out of all 3. So I look at my a and the c here. I've got a 4, which could mean a 1, 4, or a 2 and a 2. And the 49, it looks pretty ominous, but it's really a 149. And the only other factors of that are 7 and 7. Okay. So this one is the first one. This is the first example we've had where it seems like we have a couple of choices for that first one. So I can't, I don't know for sure what the first 2 terms are for the first time. Okay, it could be a 4x and an x, or it could be a 2x and a 2x. Okay. So intelligent guess and check would tell you, let's try the 2 and the 2 first. Okay. So I'll pencil that in. I know it's an x for sure. I'll pencil in a 2. Okay, so I'm trying the 2 out to see if it works. It may or may not work. And then over here, we've got our 7 and 7. So I'll pencil those in too. So I can see that based on the numbers, they're going to allow me to create the first and last term, 4x squared and a 49. Will they help create the middle term? Okay, and you can see I've got a 14 and a 14. I can't create a -35 from a 14 and 14. So that 7-7 combination doesn't work. Okay, so I erase that, and I move on to the other combination, 49 and 1. Well, I don't even have to really pencil this in here because I can see I'm going to get like 98 and 2. So that is definitely not an option. So I know that neither of these pairs work with 2 and 2. So that means that 2 and 2 don't work. So I go back and change it to the other pair that worked. So the 1 and the 4. So I've got 4x and x. And again, I'll try the 7 and 7 first. So I know these 2 should be right, the 4x and the x. I'm still hoping that the 7 and the 7 are right. They may not be. Okay, so in this case, when I do my multiplication, okay, I want to create a 35. So here I got a 28, and here I have a 7. So that's good. If I had -28, -7, that would give me -35. So this creates the 28, so that has to be negative. This creates a 7, that also has to be negative. Okay, so there's our final answer. Okay, and this one you can see, we almost had to go through all the combinations before we got the right one. but it still wasn't that bad in terms of the amount of work. Okay, and again, you can check your work by expanding. Okay, I know this video is taking a long time, but I wanted to put them all in one video so you could try as many examples as you'd like. Okay, last one for complex trinomial. 6x squared plus 7x minus 49. Okay, so just do intelligent guess and check. So with the 6, what are the factors of 6? We got 1 and 6, 2 and 3. So we have two pairs that could work. And then the 49, we've seen that before. Excuse me. Okay, so the 49 has factors of 1 and 49, 7 and 7. Okay, so we build our brackets first. And again, we've got a choice of two pairs for the first term. So it could be x and 6x or 2x and 3x. So intelligent guess and check says let's use the ones that are closest first. So that's the 2 and the 3. So a 3x and a 2x. Okay, not sure if they're going to work, but for now let's just put them in. And then for the other numbers, they're going to come from here, and we're going to do the 7 and the 7 because they're closest together. So lightly pencil them in, and then do your outside-inside multiplications to try to get the positive 7x. So here I get a 21 on the outside. Here I get a 14. So can I create a 7 from a 21 or 14? Yes, I can. If I had positive 21 and negative 14, that's going to be positive 7. So I need a positive here, and I need a negative here. And that is our final answer. Okay, so hopefully you're seeing that method and the real benefit of doing it that method in terms of speed. Okay, so now we're going to move to, let's go back to our original sheet here. So we've done common factoring, simple trinomial, complex trinomial, difference of squares. So difference of squares, it's basically like a little formula. So rather than show you where it comes from, well, if you had something that looked like this, a squared minus b squared, I'll put brackets around there, just the factors of that are going to be a plus b, a minus b. Okay, so let's do a few examples. Start with something simple. And again, you should always check to see if there's a common factor, just like the last method we looked at. So I've got x squared minus 9, okay? So first thing I try, common factor, nothing there. Okay, now there's a little checklist that you do to see if you use difference of squares factoring. Okay, the first two are pretty easy. Difference of squares means you have two terms. Okay, so I have a term, two terms, and difference means the subtraction sign in between. So the first two things are checked off, and then the last one is, I don't think this is a real verb, but you check to see if you could take the square root, or if the two terms are square rootable. Okay, can I take the square root of x squared? Sure. Can I take the square root of 9? Yes. Okay. So if you can do that, then you definitely use difference of squares. It definitely will work. Okay. Now, here is the secret to using this method, and if you follow it, it makes these super easy. This should be almost easier than common factoring, I think. And it also helps if you do this method, apply it to the last method, which is our new method. it's very similar. So anytime I know that I'm going to be using difference of squares, I immediately write this little template here. Empty bracket squared minus empty bracket squared, okay? Because that's a difference of squares. That's something squared minus something squared. You just have to be able to turn this into this. So what do I have to square to get x squared? Well, that's pretty obvious. I got to square x. And what do I have to square to get 9? I have to square 3. So what this tells you is this is like your A and this is like your B. So you can go directly here to your final answer. Okay, so it's going to be, and this is the way I would do it, whatever's in the first bracket is your first term of both factors. Whatever's in the second bracket is your second term of both. And then you have a plus and a minus. Does it matter which order? No. Okay, so that's how easy it is. Okay, but I really think this is important, especially once you start seeing trickier looking ones, which we will see. Say you had 4a squared minus 25. Do your checklist, two terms minus a subtraction sign. I can take the square root of that. I can take the square root of that. Now, when I say take the square root, I mean that it goes evenly. Okay, if that was a 26, it wouldn't be square rootable. So you're looking for numbers here that are that are perfect squares, and you're also looking, if you have a variable, that it's got an even degree power. Okay, so if you had a cube here, it's not going to work. Okay, so first thing I do my template, and then I put in, okay, what do I have to square to get 4a squared? Well, it's definitely an a, but if you put a 4 here, would that be right? No, because you'd have to square it, and that would give you 16, which is wrong. So what do I have to square to get 4? I have to square 2. So 2a times 2a is 4a squared. What do I have to square to get 25? That would be 5. Okay, so this is how easy this method is. Okay, I know the first term of both factors is 2a. I know the last term of both factors is 5, and I have a plus and a minus. Done. Okay, 17, 4x squared. So it looks pretty similar to the last one, other than the variable there. But this is where you might fall in the trap. We couldn't do any common factoring for the first two, but we actually can for this last one. Okay. Now this is a very deceiving question, because I fall into this trap myself. You look at that and you go, okay, I'm going to go directly to difference of squares because I can see that it will work, and it will work, but you'll be forgetting that there was a common factor that you could have taken out right at the beginning. Okay, so what can we take out? We can take out the 4. And when I take that out, I'm left with x squared minus 4. No. I'll just do this the long way for now. So in the brackets here, this is where my template goes. I've got x squared minus 2 squared. Okay, a lot of people go directly from here to the final answer. I'm just showing you using the template. So I know I've got my 4 as a separate factor. I've got my 2 binomial factors start with x. They have a 2 in them, and we have a plus and a minus. Okay, so now what would happen if you didn't do this? I believe you'd have like 2x plus 4, 2x plus 4. Sorry, 2x plus 4, 2x minus 4 as your answer. But if you look at it, you go, wait a minute, I can take a 2, factor 2 out of both of those factors, and then those two factors of 2 become 4. So it's always better to do it at the beginning. It's a lot less cumbersome. If you can make your numbers smaller by factoring out, you should. Okay, number 18. This one's a little trickier, but you'll see why that method that I just talked to you about is beneficial. Okay, so you've got 100x to the fourth y squared minus 9z squared. Looks tricky because we got three different variables. We got an exponent of 4 there. So what I would do is do the checks, two terms, check, minus sign, check, square rootable, square rootable, square rootable, everything's square rootable. So we go ahead and I can't common factor anything out of here. So I immediately write my template here. Okay, now what do I have to square to get 100? That would be a 10. Now this one's a little trickier. What do I have to square to get x to the fourth? I would have to square x squared. Remember the power of the power rule? That would give me x to the fourth. And y squared means I should put a y here. And this would be a 3z. Okay, so now that we got our things in brackets, this is the real payoff. Make my brackets a little bigger. I know the first term is 10x squared y in both factors, and the second term is 3z, and I have a plus and a minus. Okay, last example, and this is a bit of a tricky one, and you might see this one in the future. So this is how you'd handle this. X to the fourth minus 16. So it looks actually easier than this one when you first see it. Okay, and I do my checks and they all work. So I know this is definitely a difference of squares. So I write my template out, and easy enough, that should be an x squared, and that should be 4. So looks like the factors are, I have an x squared first term, and I have a 4 here, plus and minus, and you would think you would be done. However, this factor is still factorable. Okay, this is another difference of squares, because if you look at it, I've got two terms, subtract the sign. I can take the square root of x squared, I can take the square root of 4, and when you do that, well, the first thing is this is not a candidate for difference of squares, only because that's a plus. Okay, it's not the sum of squares, it's a difference, so it has to be a minus sign. This one is, and I can actually factor that into x plus 2, x minus 2. So sometimes you might get a question like this where you actually do the difference of squares method twice. I haven't seen one with 3 times, but it's definitely possible. But here's a nice simple one that has 2 layers or 2 levels of difference of squares. Okay, a lot of people would just leave it like this and think they're done, but I would say that this is factored correctly, but it's not fully factored because there's another degree of factoring here. Okay, so that takes us through the review. So now what we're going to do quickly is the sum of cubes, difference of cubes, which is our new method. Okay. So sum of cubes, difference of cubes. Now this won't take that long because it's very similar to difference of squares. Okay. Okay, so just like I did with the difference of squares, where I said a squared minus b squared is equal to a plus b, a minus b, those are your factors. So if I had something that looked like a cubed, now I've got sum of cubes and difference of cubes. So I'll just do the sum one first. So that would mean a plus sign between the two terms. A cubed plus b cubed. Well, that you can see by looking at it, those are 2 cubes and they're adding together, so that's the sum of cubes. Okay, so the actual, and this is something that you would actually memorize. It's not that hard. So this factors, once you know what a and b are, the factors are a plus b is your first factor. That's a binomial. Your second factor is actually a trinomial, and that's going to be a squared. Whatever a is, you have to square it. And then the sign that comes next will be the opposite sign to this. So in this case, that would be a minus ab and then plus b squared. Okay, so that's the formula for the sum of cubes. The difference of cubes are very similar. Okay, so the only difference is the subtraction sign, so the plus sign. Okay, so what changes here? The binomial factor has a minus sign, so these you can see these signs match up. Okay, but if you're comparing these two, the sign flipped. Okay, now this is almost exactly the same. A squared plus b squared are on the ends, and the only thing that changed here is the sign changes for this. So that's plus ab. Okay, so those are, you have to know what this is in order to do sum or difference of cubes. Okay, so let's start off with something straightforward. X cubed plus 8. Again, you can do a check. Okay, you would check that it's two terms. Yes. A plus sign means it's the sum of cubes, and you can take the cube root. Okay, so definitely if it's something to the power 3, that's already cubed. But it could also be to the power 6 or power 9, any factor of any multiple of 3. Okay, and I can evenly take the cube root of 8. So this will be something new to you, but this would be, you have to kind of know what your perfect cubes are. Now, fortunately, the numbers don't get too high. So the perfect cubes are 1, 8, 27, 64, 125. So they go up pretty quickly because they're cubing, but as long as you know what numbers you're looking for, it's not too hard. So again, just like difference of squares, I know this is going to be a sum of cubes, but I want to write it in a way that looks like more like the sum of cubes. Okay, so something like this. So I know this is pretty straightforward. The x goes here, and what do I have to cube to get it an 8? Well, I have to cube a 2 cubed. So this is like my a, and this is my b. So now what I do is I go right to the final answer. So the first factor will be a plus b, so that's x plus 2. And then the other factor is a trinomial, so the first term will be a squared, so that's x squared. I'll do the last one. The last term will be 2 squared, so that's a plus 4. And then the middle term is, we're basically multiplying the a and the b together, so that's 2x, but it's a minus 2x. Okay, and we're done. Now, you may look at this and say, hey, maybe I could factor this trinomial. You can never factor this trinomial. Okay, so don't waste your time. You're always done as soon as you plug in the right values into this formula. Okay. All right, we're going to do 3 more and then we're done. So 64x cubed minus 125. Okay, you can see because of the minus sign that this could be a difference of cubes. Now, are these perfect cubes? Well, you already heard me mention the numbers 64, 125. Those are perfect cubes, and since this is to the power 3, that's also a cubed number. So I'm going to rewrite this as something cubed minus something cubed. Okay, now we'll do this first. To get a 125, that's 5 cubed. To get a 64, that's 4 cubed. 4 times 4 is 16, times 4 is 64. And then x would go here. Okay, so again, that's my a and that's my b. So go straight to the answer. So remember, the first binomial factor will have the same sign as your original question. So just like this was a sum of cubes, that's a sum. This is a difference of cubes. So this will be a subtraction. So it's going to be a minus b, 4x minus 5. And never confuse the fact that you got a minus here. The sign of the b is whatever's inside here. So that's a positive 5. Okay, now the second factor, your trinomial, it's going to be, so let's be careful with this one. This is a squared. So what do we get when we square 4x? We get 16x squared. Okay, let's do the last one because it's easy. 5 squared is 25, positive. And then the middle term, multiply these two together. So we get 20x. And the sign will always be opposite of what this one is. So plus 20x. All right. So, 2x cubed plus 128 y cubed. Okay, so two different variables. You can see I got, two terms adding, so it looks like it could be a sum of cubes because I've got cube. But when you look at these numbers, they're not perfect cubes. So what's going on here? Well, we skipped by the important step of trying to do a common factor. And this does have a common factor of 2. When I factor that out, I get a nice perfect cube number, 64. Okay, and then when I write this out with the template, I get x cubed plus, so let's be careful with this, this will be 4y cubed. So 4 cubed is 64, y cubed is y cubed. And when I do my factors, don't forget now that 2 is still a factor. So I'm going to have a monomial, binomial, and a trinomial as factors. So the first factor will be x plus 4y, a plus b. And then I'm going to have x squared. Multiply these two together. I get 4xy. It's going to be minus. And then 4y all squared is 16y squared. And that's it. So this one looks tougher because you can't even do it if you don't do the common factoring first. You can't possibly do the sum of cubes. So unlike other questions where you may have noticed, you may be able to proceed and then fix your common factoring at the end. You can't do it with this method. Okay, last question. 8 x to the 6 y 12 minus 27. Okay, so again, if you want to check two terms, subtraction sign, okay, that's a perfect cube, that's a perfect cube number, and these are all powers of multiples of 3, so this will be a difference of cubes. So I'm going to write it as a difference of cubes first. So what goes inside here, that I have to cube a 2, and then to get an x to the 6th, that would be x squared to the power 3. This would be y to the 4th. So remember about the power of a power rule when you're doing this. You're not adding them, you're multiplying. Okay, and then there's 27. That's just 3 cubed. So there's my a, there's my b. First factor is it's going to be a minus b. So 2x squared y to the 4th minus 3. Then the trinomial will be this term squared. So that's 4, this one's a little trickier, x to the 4th, y to the 8th. Okay, and then when I multiply them together, I get 6x squared y to the 4th. And the sign will be opposite of that, so that'll be a plus. And then I want to square that, so I get a plus 9, and we're done. Okay, and just like all the other methods of factoring, you can always check. I know it's a little tougher to check these ones by expanding and making sure you get the original one. Okay, so that's it for the lesson. So we did a review of all 4 of the previous methods of factoring. Hopefully, if you didn't know how to do the intelligent guess and check method, or whatever it's called in your books. If you didn't know how to do that, hopefully I helped you out to be able to do that fairly quickly and understand what to do. And we also learned this 2 other new methods, sum of cubes and difference of cubes. You notice there's no, what's missing here is the sum of squares. So if you had a sum of squares like x squared plus 4, that is not factorable, okay, because you can never get it to work. So that's why that's missing, and that's why you can have a sum of cubes, but you can't have a sum squares factoring. Okay, so hopefully this will help you with your factoring. You're going to need to be able to be good at factoring in this course. So if you have any questions, please leave a comment, or if you're in my class, come and speak to me and I'd be happy to help. All right, thanks a lot. Have a great day.